This video presents you with a collection of our capabilities that showcase the product's power. To bring these concepts to life, we'll provide some real-world usage scenarios. Leveraging any or all of these features will help you deliver a much more powerful NoSQL-based application than anything you've previously experienced. We'll go through some of these capabilities in detail in the next few minutes. Let's begin with an exploration of how FlexVertex lets you define multiple data models, thus eliminating the need to deploy separate point solution databases. We're starting with a travel-oriented system. In this instance, we're using graph capabilities to tie together objects such as travelers, flights, credit card applications, and interests. Remember that to query this graph in any direction, all that's necessary is a starting point, such as a traveler name or category, an interest, or a flight number. Also remember that data objects aren't the only objects that store properties. In FlexVertex, you can also associate properties with connections themselves since they too are represented as objects. Now we're moving on to document-oriented data related to travelers and flights that in first generation, NoSQL would have required a specialized document database. No longer. FlexVertex can easily incorporate this type of information into your overall data multiverse. And this means that starting with an interest or flight number, it's now possible to include those documents in a larger graph query. As the flight moves along its path, it's possible to use FlexVertex to store its location. And once again, because all information is stored as objects, this time series data can be located from any starting point in the FlexVertex data multiverse. And vice versa, all that's necessary is a single flight location to find the travelers that are booked on it, their interests, and any special requests that they've made. The same holds true for more traditional tabular data, in this case financial transactions made by the traveler. And because everything is connected, you can start a far-ranging query across the data multiverse with a single transaction. Finally, we're tracking key value information related to the credit card application we described a few moments ago. Here too, any information stored in the data multiverse can be reached from anywhere else. Object orientation is at the heart of the FlexVertex architecture. This means that you no longer need to flatten or otherwise alter your application's data structures, and can take advantage of key object-oriented capabilities such as inheritance and polymorphism. Here's an example of class inheritance in action. We're starting with 3 base classes, which will form the foundation for derived classes. You're free to define these classes as abstract, meaning that they don't hold data, but instead only provide structure for their derived class. Whether or not they're abstract, you're free to query them to see what they hold, as well as what derived classes contain. We've now derived 2 classes from those base classes. This means that we can run queries against the person class if we want to see employees and customers. Otherwise, we can write queries directly against those derived classes. And FlexVertex lets you derive as many class levels as you need. Which is what we've done here. You can issue queries against the manager, staff, VIP or standard classes, or anything above them in the class hierarchy. Earlier in this series, we described how FlexVertex separates its core service from the database layer. This separation of concerns makes it possible to offer different storage engines for different needs. Developers and administrators may opt for single server approaches such as in-memory and embedded in process, to a single client-server configuration, and then onto multiple servers each running the FlexVertex container. It's also essential to remember that all application code you write is also storage system agnostic. This means that you can develop using one storage engine and then switch to a different configuration as your needs evolve. The FlexVertex data multiverse information hierarchy makes it possible for developers to create extremely sophisticated enterprise information architectures. You can construct your application with confidence, knowing that just about any kind of data representation you need, including multi-tenancy, will be feasible. It's comprised of 3 specialized layers: domains, nexuses, and schemas. Each of these constructs plays an important role in organizing your enterprise's data. Domains represent either an organization if you're operating within a single enterprise, or can be assigned to different customers if you're building a multi-tenant software as a service solution. Nexuses reside beneath a domain. These are primarily used for subdomain organizations. For example, for regions, there could be nexuses for North America, Asia, Europe, Africa, and so on. If you prefer, you could establish functional nexuses like manufacturing, sales, and finance. Placed below nexuses, schemas are conceptually like a database. They hold definitions for classes, object instances, indexes, and much more. Each application can have its own schema, or you can share a schema across applications. And remember, if permissions allow, it's possible for a user or system to interact with other schemas, nexuses, and domains. This slide shows three different hierarchies. At the top left, you can see a single organization domain, with country-specific nexuses and schema beneath it. At the top right, you can see a hierarchy that's more functional in nature, with nexuses tied to specific types of applications. Finally, at the bottom you can see a hybrid approach. Some nexuses are geographical, while others are departmental or even functional. Beyond raw power, FlexVertex supplies its developers with a variety of capabilities to simplify their tasks. We'll describe that next.